Hey everyone, welcome back to my channel where I talk about all things tech and finance. And in this video, I'm going to be going over the overall process of trying to beat the Dinosaur game that you often play on Google Chrome if you don't have any internet connection. I'm going to go through the process on how to try to beat the Dinosaur game with a combination of screenshots and computer vision, and everything I'll be doing on this video and throughout this entire miniature video series will be in Python. And so there will be three parts that are associated with this miniature video series. The very first part will be the data engineering aspect on how I'm actually trying to get the data and clean the data in such a way that I can use the data for the tuning aspect. The second part, so I'm going to be looking into various models that can potentially hit this particular problem right on the nose and hopefully get a successful run through and beat the entire game. The third aspect is trying to incorporate the model in runtime to integrate this particular model with incoming streaming observations and then have a prediction on runtime so that the dinosaur can go up and down without me clicking anything or pressing anything on the keyboard. Okay, so this is the Dinosaur T-Rex game that I'll be playing. I'll make sure I put a link in the description if you want to play along. But essentially what I'm going to be doing here is that I'm going to be maximizing the amount of pixels that are on my screen, and I'll be making sure that when I take a snapshot of my screen that I only want the relevant information, such as the ground over here. So basically like this very small box. Let's see if I can do that. Yeah, and so whenever I push down a key, I want to record what type of key is associated with which type of instance of where the dinosaur is either jumping or ducking or pretty much doing nothing at all. So there's going to be a tagging mechanism. So we're going to have somewhat of a binary classification where a snapshot is going to come in and what it has to determine whether or not the dinosaur will jump, or will it duck, or will it do nothing. But the nothing part won't be coded into the instance. So we're only going to have two keys, jumping or ducking. So it's going to be somewhat of a logistic regression model or some version of a more advanced like neural network, for instance, like a ResNet. So this is going to be the basic structure that I have going on for the dinosaur game. I have a folder just called window capture. It's just going to be capturing all my screenshots whenever I'm playing the game. And I'm going to be storing the screenshots inside of this data folder. The utils folder is going to be my helper functions that are associated with capturing my key input. And then my main function is going to be related to just getting the screenshot data and making sure everything will run here. Now, if you want to follow along with this project, I will be making sure that I will include all my requirements in terms of in terms of what type of packages that I have installed. So if you want to follow along, feel free to pull down my repository from GitHub and go ahead and download all these associated packages that I'm using throughout this entire project basis. Let's get to the meat of this all. So let's create a new file. I'm going to create a getKeys.python file. This is essentially just going to get the keys, so get keys from keyboard. That's pretty much what this entire, I guess, localized Python library will help me in doing so. Although there are a few packages that I'll be using that are Windows oriented, and so for all my Mac lovers out there, you guys might be out of luck if this does not run on your machine. However, there are two ways that you can try and get out of this particular predicament. One of them is to go through the Google Colab. You essentially just copy and paste all my code onto the Google Colab, and there's going to be a few packages that you're going to have to manually install. You just have to do the the exclamation point with a pip install whatever package that is on their cloud systems over there. The other part is for me to Dockerize my entire system. So I could do this. This could be like a fourth video down the road if there is a lot of interest. So if you are interested, please let me know down in comments down below so I can make sure that all the operating systems are sort of irrelevant in this case when you are running this type of code. So this is my get keys package. So what's happening here, start right here. So this is my key list array. These are the only values that I want recorded. So very first value is going to be the virtual key, and this is also related to the Windows operating system machine. So do note that your values might be different if you're on like on a Linux or a Mac OS. But this is, I just want to record the hexadecimal for the space bar, hexadecimal for the letter Q, and then the arrow key for up and arrow key for down. So the values that I got are associated with the virtual keys on the Windows website. I'll make sure I attach a link in the description if you want to check that out. But each of these codes, each of these hexadecimals or constants are associated with which type of key that may or may not actually be mapped to the keyboard, or it will be registered 0 in terms of like an ASCII table value. So this is like your all-be-all guide in terms of which type of key that you want registered or to be understood by your specific program. Okay, so once I have my key list, I'm just going to be iterating through the key list to double check whether or not there is a specific instance that actually exists within my operating system. And so this is where it's going to make sure that all my values inside of this list are appropriate and they actually do exist. And so once I have all these key values inside my array, I'm just going to be checking, I'm going to be running the get keys in my main function inside of my so once I get the keys, it registers whether or not I press a specific key, and it matches to see whether or not a specific value is inside of my array, and if so, it'll do a specific action. So that's the thought process behind this keys function here, and it'll make more sense once I start integrating all of my specific packages inside my main. This is the main function, which houses the architecture for capturing live dinosaur data. There will be 2 while loops involved. The first while loop will be related to whether or not the user wants to begin the program or exit out of the program, using the spacebar or the letter Q, respectively. The second while loop is where the magic happens. This captures how fast my machine is at capturing a screen in terms of frames per second. In addition, it is waiting for specific keys to initiate its given command. Remember that the value x51 is the hexadecimal value for the letter Q. Otherwise, each other command, the up and down arrow keys, will record keyboard input with a given screenshot. Within the Dinosaur game, you have the option of using either the spacebar or the up arrow key to jump over various obstacles. Just to be consistent, I will only use the spacebar to begin the game and the up arrow key to jump over obstacles. At the end of the loop, I will ensure that the values that are depending on each other will be stored in the data folder, which will then be used to tune a given machine learning model. Okay, now that we have all of our keys set up, let us now work on the screenshot portion. So the screenshot itself is actually, it's actually just called window capture. I already did this in the background over here, but essentially a lot of inspiration and a lot of help came from Learn by Coding. So do make sure to check him out on his process on basic codifying gaming. Very useful, and I use a large majority of his code in terms of trying to take a snapshot as fast as possible so I can get as many frames per second as I can. There are a few things, of course, that I changed on my end so that it's more compatible with my system, but there is one thing I wanted to highlight which was extremely helpful, and that was using this function over here. Pretty much our entire system depends on locating a specific window in order to take a snapshot of. So I already imported the necessary packages and the necessary function over here. So let's run that function to see what that does. And this is essentially just printing out all of the available known windows that are on my system that are visible. So notice here, Anaconda prompt, Anaconda 3-Python, that is the name of this window. So with our dinosaur game, we are going to be looking for this right here. And we're just going to be looking for that particular string, and we are going to be pinpointing the screenshots to that specific string itself, and so that it's always locating that specific window, and we don't need to worry about interfering windows and whatnot. So let's go ahead and code that portion up, and we want to make sure that's the first thing that we do. So we do like a Windows capture is equal to window capture, and also we want to make sure that we actually import this. So it'll be like from utils dot window capture import window capture. So we want to import this and the name of the string. Let's pull that up. And the name of the string is that. So put that right here. So that is the name, and that is the window name. So we're going to be locating that window icon, and then we're going to be running the necessary values. And then once we have the values, we just want to make sure that we are actually using this function here the get screenshot, and we're going to be incorporating the get screenshot for whenever we are pressing the button up or down, the up arrow key or down arrow key. And so let's do this. So within the second loop, we know that we want to take the screenshot here. So it'll be a screenshot WinCap.screenshot or screenshots over here. Take that screenshot. I think it's get screenshot. Yeah, get screenshot. Let's put that here. And then we already have a screenshot. So it's automatically taking a screenshot. However, we only want to record the screenshot that's associated with the up arrow key or down arrow key. And we are going to be doing like something like an image append or image data dot append value of the screenshots. And we are going to be storing a image data like at the very beginning over here. So it'll be like image data and targets. Targets that is equal to, maybe we need to create like a get data function over here. So let me get that situated with the getters and helpers. Okay, so these are my two functions that I'm using to utilize. Essentially, I use this get data function and the save data function from this repository, Clarity Coders. Very, very helpful as well. But essentially, the get data is checking to see if there's a Numpy array that is located in my data folder that I'll be having up here. Since I don't have anything here, it'll just create from scratch, and we're gonna have like image data and targets to be storing our data in. Then of course we have our save data. Same thing, same idea. It just saves all of my appended data from here, from the get data portion, and it will append the existing data on an existing Numpy array, or if there's nothing there, then it will just create a new file altogether. And these are the two file names that are going to be associated with, you know, me storing my objects. So I have my screenshots and got my command keys situated there. Okay, now the last piece that we need to do is that we need to actually start appending our data. So we have targets dot append and our key system over here, which is going to be a space, up arrow, down arrow, and that's it, actually it. And yeah, good. So I initialize my get data, which should be an empty array, or if it is an existing array, it'll just load that in and start appending data from there. Okay, so we have that, and we also want to do that with this. And I believe that's all I really need to do. Let's do save data here, image data, so that we're actually keeping track of our results. And we have a target here. So let's go ahead and start running this program and see what happens. Okay, so note that I've already captured the pixelated rectangle that will be capturing the dinosaur, the ground, and the incoming cacti and the birds that will be trying to terminate my game forming. So I'll be running the python main.py, and notice that all of my frames per second are being outputted, which is totally fine because I'm not actually starting the game and I don't have the associated clicks that are associated with the screenshots in order to save them. So notice that when I press a spacebar, we got some output over here, and the spacebar value, the hexadecimal value, is 32. The up arrow key, which I'm doing right now in terms of just jumping, has a value or hexadecimal value of 38, and then the ducking procedure is a value of 40, and this is the ducking. So I will essentially be playing lots of games in order to have a healthy data set to capture when the dinosaur is going to jump, when the dinosaur is going to duck, and the other values that are associated in terms of me, you know, starting the game and having that hexadecimal value of 32. I will just filter out those observations because that is irrelevant. So that's me ducking right here. So that's really cool. And okay, so let's just quit out of this, and I already failed, but let's quit out of that program and see if our Numpy array has been populated, which it has. We got command keys and screenshots, and see how much data that is. Yeah, so this is the data that's been captured. So just note that even one game, that's very close to 1 gigabyte of data. So I probably will play maybe close to 8 or 10 games, and 10 gigs of data should be enough to determine whether or not the dinosaur should be jumping or ducking when the objects are coming on in. Okay, now that we have that out of the way, we have our data. Now comes time to actually exploring what type of data we have and how we can actually maybe perhaps tune our given model. So first things first, we just essentially just load in our data. I just conveniently included some of the functions I had inside of my modularized setup. So within this Jupyter Notebook, it will still be a part of the GitHub repository. You can just go ahead and run that and see what happens on your end. You can go ahead and start testing out, your various screenshots and how they look like. And I just went ahead and copied and pasted the large majority of my code onto this Jupyter Notebook. So the main part I want to go over is what our Numpy arrays look like. So these are my target values. This is the command keys captures, and as you can see, we have 38s, 32s, and 40s. So those are associated with each screenshot associated that is actually captured. So within each of these screenshots, we can look at what type of screenshots they are, and these are just the Numpy arrays that we conveniently stored inside of our folder structure. And we have 638 observations, and these are the dimensions of the given screen capture. And notice that we have 638 targets, so they do match, and they are like a one-to-one observation in terms of the sequential order. Now we can actually take a look as to what type of figure we are working with, and you can pretty much just check out how many or like what type of instance of this particular image is. So this is the 5th observation. We can look at like the 10th. We have that jumping, and we can look at what the target value of what that 10th observation is. I think I'm missing an S here. But that's 38, so that's jumping, so that is correct. So you can go ahead and go through your Numpy array and check out what type of, that should be also jumping, and what type of values associated with that. So if we were to look at the very last value, it's like a game over. Yeah, like that little recycle, I don't know what that's associated with. It could be like jumping or crouching. Okay, so it's supposed to be jumping here. You can go through what types of categories that you have and see the distribution of how many jumps, ducks, space bars that you have in your data set. You can figure out how to munch your data. So that's what I'll be doing in my next video. It'll be the modeling effort to pretty much capture these objects that are in this image and determine whether or not our little dinosaur here, guys, should be jumping or should be crouching or just, do nothing. So if you like what you saw, make sure you leave a like, hit that subscribe button while you're at it. And if you have any questions, feel free to leave a comment down below. And if you made it this far, I hope to see you in my next video. Thank you so much for watching.